Okay, guys, this is for a review for differential equation. So that will be a review for the first section, which is section 2.2, which is differential equation, solving differential equation, first order differential equation by separable method, which means we separate a function of x with dx and a function of y with dy. Now, whenever we have the ability to separate f of x with dx and a function of y with dy, we call the equation separable equation. Let's start with the first question here. We have the equation dy with respect to x equal to sine of 5x. Multiplying by dx, both sides, we will get dy equal to sine of 5x dx. Now, are they separated or not? Here we have dy only, and there I have dx. What I have here is only a function of x, so they are completely separated. So the next step, integrate integrating both sides means integral of 1 dy, integral of sine 5x dx. Integrating 1 dy will give me y. Integrating of sine 5x, it will be minus 1 over 5 sine 5x plus a constant number. So that will be the solution of the differential equation. Remember in calculus 1 we say integral of sine any constant a times x dx, it's minus 1 over a cosine ax. Plus constant integration. And remember for cosine ax dx as well, will be 1 over a sine ax. Now, second question, here we have step 1, we need to multiply by dx, so I have dy. So step 1, I say here dx, so you will get dy equals to 1. Are they separated? Yes, because here we have a function of x with the dx and only constant with dy. So our next step, integrate integrating both sides means integral of 1 dy equals to integral of x plus 1 squared dx. Here you can integrate two different ways. One of them is you just add 1 to this, will be to the power 3 divided by 3 plus constant c. Or some of you will forget that idea, so they might go and say, I will expand x plus 1 all squared, so it will be x squared plus 2x plus 1 dx. Then they will say that is y equal to 1/3 x cubed plus x squared plus x plus constant. See, both of them are correct because we have ax plus b all to the power n dx, that is 1 over ax plus b raised to the power n plus 1 divided by n plus 1. Either using plus constant, either using this formula or you want to open it, you can open it, but no need. Now, the differential equation. So our first step is separate or multiply first by dx. By dx to separate. So if we multiply by dx, we get dy equals to e to the power 3x y times dx. Now, in order to separate, we need to use math one idea, which is if I have a base raised to the power x plus y, we can say it's a to the power x times a to the power y. Using this property from math one, I should be able to do e to the power 3x times e to the power 2y dx. Changes now. I have here dx, and I have here a function of x, but here I have a function of y, and here is dy, which means we need to divide by e to the power 2y to separate. So if we divide here by e to the power 2y, and here by e to the power 2y. Of course, when we divide by the same quantity. So e to the power 2y will cancel out, and I will get e raised to the power minus 2y dy equals to e to the power 3x dx. Now, our next step, once we separated, we integrate both. Integrating both sides, integration of my e raised to the power minus 2y dy, integration of e to the power 3x dx. Remember in calculus 1 or calculus 2, integration of e to the power ax, it's 1 over a e to the power ax. So when you apply it here, you will have minus 1/2 e raised to the power minus 2y equals to 1 over 3 e to the power 3x plus constant number c. So that would be the solution of the differential equation. We are continuing the same story. What I have here is to one is multiply dx to separate. So I will have e to the power x times y dy equals to e raised to the power minus y e raised to the power minus 2x minus y. All of them multiplied with dx. We apply the same story when we have a plus a to the power x plus y. In math one, we said it's a to the power x times a to the power y. So this means I have e to the power x times y times dy equal to, here I do nothing, but here I have to separate by, this is e raised to the power minus 2x times e raised to the power minus y. Now I need to take a common factor. This is e raised to the power minus y, and e raised to the power minus y, it's a common factor. So I'll take it as a common factor, e raised to the power minus y. What is left inside the bracket? Here it will be 1 plus, here it will be e raised to the power minus 2x dx. Now, I have here function of x, sorry, dx with the function of x, but also I have a function of y. And here I have dy with a function of y, but also I have what? Now we need to divide by quantity to separate a function of x with dx, a function of y with dy. So we decided to, if I have dx, I need to get rid from this quantity. So I need to divide by e raised to the power minus y. And here I have dy, so I need to get rid from e to the power x. So dividing by e to the power minus y times e to the power x on both sides. They said when we divide both quantities. So these are cancelled now. and e raised to the power x would cancel with e raised to the power x. This means after simplification, this one can go outside. It would be y times e to the power y dy. What here? Remember in math one, a b over c. That means you can say it's a over c plus b over c, or you could say a plus b over c e raised to the power minus 1 a plus b, then you multiply the same. So here I could say it's e raised to the power minus x, and that is 1 plus e raised to the power minus 2x. Then I multiply, so I will get y e to the power y dy is equal to e raised to the power minus x plus e raised to the power minus 3x. Now we next step integrate both sides. We integrate y times e to the power y dy integration of e raised to the power minus x plus e raised to the power minus 3x dx. Remember we said we have a rule integral of e to the power ax dx. It's 1 over a e to the power ax. This means here I need to use tabular method. It's a special case of integration by parts. So you will say here, this is u, that's dv. U is the polynomial, which is y. It's a derivative 1, then a derivative of 1 is 0. And e to the power y, its integration, it's e to the power y. And again, that's e to the power y. We skip the first one, it is plus, then minus. So integration of this part will be y e to the power y minus e to the power y. What about integration of this part? Integration of e raised to the power minus x will be negative of e raised to the power minus x by applying this rule, and that's minus 1/3 e raised to the power minus 3x plus a constant. No. Now, we continue the same strategy. The first step is to separate. We have e to the power y plus 1 squared times e raised to the power minus y dx e to the power plus 1 to the power 3 e raised to the power minus x dy equal to now. Here, what I have is I have dx, but here we have function of x, nothing here with respect to x. And here I have dy. I have nothing with respect to y here, but I have them here. This means we need to define quantity. If I have dx, I need to get rid from these. So I need to divide by e to the power y plus 1 whole squared. And also I need to divide by e raised to the power minus 1. Here I have dy, but these are function of x. So I need to divide by again e to the power x plus 1 raised to the power 3 and e raised to the power 1 minus 6. Doing this division, we are dividing by e raised to the power minus x times e raised to the power minus y times e to the power y plus 1 squared and e to the power 1 to the power. here, e raised to the power x, e raised to the power minus y, e to the power y, plus e to the power x plus 1 or to the power 3. Of course, 0 divided by these quantities will be 0. So what we have? We have e raised to the power y plus 1 all square will cancel with this one. And e raised to the power minus y will cancel out with e raised to the power minus y. And this will move up. So I will get e to the power x divided by e to the power x plus 1 all to the power 3 will be x. Now look here, we have separated. This is dx, and that is a function of x only. Now, what about here? I have here e raised to the power minus x will cancel out with e raised to the power minus x. E to the power x plus 1 to the power 3 will cancel out with e to the power x plus 1 to the power 3. And of course, that one will go up. So what you will get? E to the power y divided by e to the power y plus 1 all to the power 2. 0 again, look here, we have dy, and here we have only a function of. Now, our next step is integrate. When we integrate, e to the power x, e to the power x dx, and e to the power y plus 1 dy, this will be integration of 0, which is what type of integration we have. Remember in calculus 1, we said if I have f at dx, and I have the derivative of g, this means it's integration by substitution. And then u will be g prime of x dx. And using this substitution, we will change only one familiar function. Hence, always choose u to be inside the power, all the quantity inside the power. So what I have here, it's e to the power x plus 1 all to the power minus 3 e to the power x dx. What I have here, e raised to the power y plus 1 all to the power minus 2, and that will be e to the power y dy. Look here, our choice, we have to choose two variables. The first one I will call it t, which is inside this power, that is inside the power. All the quantity I will call it t, so it will be e to the power. Now, second, we need to find what is dt. Is equal to e to the power x. Now, this means these two will be replaced by dt. And you can see we get one function with antiderivative. We know how to integrate. Same thing here. I will take to be inside this one, inside this power. So what you will get? E to the power y plus 1. And that respect to u will be equal to e to the power y dy. So these two will be replaced by du. And inside the power, now we reach the end. What's the integration of this one? Add 1. Remember, in the integration x to the power n dx, it's x. So I will have here okay. So I will have here I hope I have to wait a little too. Now, when we integrate to the power minus 2 divided by minus u raised to the power minus 1. So now we must replace the variables to its original variables, which means I must replace t by e to the power minus 1 e raised to the power x raised to the power minus 2 minus, I have to replace e to the power u by e to the power y plus 1. So I will get here e to the power y plus 1 raised to the power minus 1. Now we can say we have solved the differential equation, and that's the solution. Now, the idea is repeated, we separate, then we integrate. Let's continue. Here I have a differential equation. So I need to multiply or cross multiplication, to be honest. So I will say here cross multiplication. So the first step, x times y minus 2x plus 4y minus 8 multiply minus y minus 3. These two as two groups. That's the first group, x common factor. I will have here y minus 2. And if I take from the second group 4 common factor, I will get y minus 2 again. Now, what about the other side? Same thing I will do. I will say this is my first group because it has x common factor, and second group because it has sine as a common factor. So here what I will get, if we take x common factor, I will get y equals 3. If I take from the green here negative common factor, I think by grouping using the math one. Now I have here y minus 2 is a common factor again, and I have here y plus 3 is a common factor again. So taking y minus 2 as a common factor, what is left inside? What is left inside is x. What is left in here, it's plus 4. That's the one. Here we take, so what is left inside? It will be x minus 1. Now we are almost done to separate. I have here dy, but I have here it's a function of y, but this is a function of x. And here I have dx, that is a function of y. So we need to divide to separate. So step 2, separate by dividing. So we divide by what? I have here dy, so I must get rid from x plus 4. And I have here dx, so I must divide y minus 2 times x plus 4 y equal to y plus 3 times dx. When I divide this quantity, x plus 4 times y plus 3. What will happen? I will have here x plus 4 is cancelled with x plus 4 by y plus 3 dy. And here, this is y plus 3 is cancelled with y plus 3, and I will get x minus 1 divided by x plus dx. Now we separated, so our next step is to find a way to integrate both. Integrating of y minus 2 divided by y plus 3 dy, integrating of x minus 1 over x plus 4 dx. Remember the trick we had in the class. If I have here y plus 3, I want to make this one also y plus 3. So I will add and subtract. So adding what? I will add the same number here. I have plus 3. So I will add to plus 3 to y plus 3 and I will subtract plus 3. So if I do this one, what I will get? I will get integral of y plus 3 over y plus 3. And I have added plus 3, so I'll subtract minus 3, and I have minus 2, so that will be minus 2. With minus 3, it's minus 5 over y plus 3. And now you can check. Plus 3 minus 5 is minus 2. And that will be dy. Similarly, we do the same thing here. I have x plus 4. So I would say that is, I have here x plus 4. So I will add to x plus 4. And I will subtract 4. So minus 4 with minus 1, it's minus 5. Now, what will be the benefit of adding and subtracting? It is to cancel out y plus 3 here with y plus 3, and you will end up with 1 minus 5 over y plus 3 dy. Same thing here. You will end up with 1 minus 5 over x plus 4 dx. Now, when I integrate both sides, this will give me y, because I'm integrating 1 with respect to y, and that's minus 5 ln absolute value of y. Integrating with respect to x, so it will be integration of 1 will be x, minus 5 ln absolute value of x plus. That will be the solution of the differential equation. Now, now, going to the next example, we had the same equation. Example number 6 and 7, they are exactly the same. So it's again, this is repeated. So I have to cancel this one. This is repeated. Now we have example number 8, which is a similar idea. We need to multiply by cross multiplication to separate cross multiplication. It will be x minus 1 times dy equal to y squared minus 1 times dx. Now, again, I have here dy, and that's a function of y. But I have here dx, and that's a function of x. So we need to divide to separate. We need to divide by what? X squared minus 1 times y squared minus 1. So if we divide, separate by y squared minus 1, separate. Now, if we divide, we get x squared minus 1 dy equals to y squared minus 1 dx, and we divide by the same quantity, x squared minus 1 y squared minus 1 y squared minus 1. So this is cancelled out, and y squared minus 1 can be factored to square root of the first minus square root of second, square root of the first plus square root of second dy. Same thing here, y squared is cancelled, and I have here 1 over Square root of the first plus square root of second. Now, in order to integrate, we will use partial fraction decomposition. Do partial fraction decomposition of 1 over y minus 1 over y plus 1. It is x. So if I know how to do partial fraction of the first one, I don't need to do the second one because they are very similar, only the change in the letter. So we will say to separate or to do partial fraction decomposition, we have a constant number a divided by y minus 1 divided by y plus 1. How to find a and b? It's very simple. A, you take everything except y minus 1. So everything means 1 divided by y divided by y plus 1. So we just ignore the quantity y minus 1, but we have to evaluate with the zero of this factor. The zero of this factor, y is equal to 1. So we need to evaluate at y equals to 1, so I get 1. Same thing, b. I will take everything except this quantity. So everything means here I have 1, so it is 1. So we ignore only y plus 1, so we get y minus 1. But we need to evaluate when y equal to minus 1, which is a zero of this factor. The factor, the number which makes it equal to 0. So when you substitute, you will get minus 1. Of course, a and b in the left-hand side will be the same in the right-hand side. That's why we don't repeat it. So we will say what we have, it's 1/2 1 over y plus 1 minus 1/2 1 over y minus 1, and all of this one is multiplied with u1. Same thing we said, I have 1/2 1 over plus 1 minus 1/2 x minus 1 times x. Now, in order to get rid from the fractions, I will multiply all the equation by 2, and I will integrate. So integration of 1 over y plus 1, I multiply here by 2, minus 1 over y minus 1 dy. And here I will have, as I said, we multiply here by 2, here by 2, here by 2. So we'll get 1 over x plus 1 minus 1 over x minus 1 dx. Look here, Shabab. Since I will have here logarithm, 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 I will say here also plus logarithm c to make it simple, easy. So that will be integration is ln absolute value of y plus 1 minus ln of absolute value of y minus 1 equals to ln absolute value of x plus 1 minus ln absolute c. Now, here we have to apply logarithmic rule. If I have subtraction, we can change it to division. Okay. Now, this can be changed to, again, we have to be patient. Then divided by y minus 1. Change it to absolute value of y plus 1 will be changed to division over x minus 1 with the constant. Now, one-to-one property for look over y minus 1 is divided by x equal to 2y equals 1 over 2, which is 2 plus 1. Okay, this means c equal to 1. If c equal to 1, so y minus 1 x plus 1 over minus 1. If I will have x times y will be xy, and x times 1 will be x, then minus times plus 1 is minus 1. That is equal to, again, x times y will be xy, and x times minus 1 will be minus x, then 1 times y, 1 times minus, 1 times y will be plus y, and 1 times minus 1 is minus 1. So this means minus 1 is cancelled with minus 1, and x times y will be cancelled with x plus y, and I will have here, if I move minus y to this side, to the other side, the right hand side, I will get here 2y. If I move x minus x to the other side, I will get 2x. So dividing by 2, our solution will be y equal to x is the solution. Now, here we have again to separate. So what I have is a statement different x to the power 4 plus x times dx equal to 0. When I and that's a function of y. This is okay, but this is a function of I need to get rid of, and I need to get rid of from that one, so I divide. So here I will have here 1 plus x to the power 4 and 1 plus 4 y squared. We'll have 1 over 1 plus. This means it's 2y all squared. Here plus x to the power 4, which is x squared whole squared. This would be integration by substitution. So to integrate, use integration by substitution, or which is 2y, which means du will be execution. I will choose t to be equal to 2 times x dx. Again, I need 2 and 2, so I will multiply by 2 all the integral of 2 over 1 plus, and I will have here dx 0. So an integration for constant 0 will be, now doing the substitution, I will get 1 over 1 plus 2u, we say it's u, so it will be u squared du. And here, doing the substitution, I will have 1 over 1 plus t squared t constant. Both of them are tan inverse, 2 plus tan inverse constant. Now we did not finish. We have to replace back u and u by 2y, so I will have tan inverse of t, which is t is equal to x squared. The last step is to use the initial value to determine what is c. If y is 1, x is 0, so that will be tan at x equal to 1y will be 0. So tan inverse of 0 of 1, x is 1, y is 0, should be equal to c. Tan 0 is 0, and your c will be equal to y over. So solution of the differential equation will be tan inverse of 2y squared is equal to y over. So that will be the solution of the differential equation. Now, I have 2 more problems, so I'll stop here. So let's check this one. Stop sharing and stop recording.